Hello there. Welcome to the archive. Today we will be making pressure sensors, 2 of them, to fit in these 2 bags. I've already pre-folded some aluminum foil, which is the primary conductor. And oh crap, I forgot to bring the insulator. Just when you think you have everything and you start and then you realize you don't have everything. That's just... Yep, I don't have an insulator. Let me get an insulator, aka paper, and I'll be back. Paper, paper, paper. I guess. Do I have different paper? No. Yes, maybe. Perfect. Paper. Hello. Hello, I'm back. I have paper. So, materials needed for this thing. Also, how... Oh. The video feed is quite delayed. Oh well. We'll deal with it. Paper. Aluminum foil. We're gonna position the paper and aluminum foil on either side. And that's a standard passive pressure sensor, capacitive. What we're gonna do is make a large one and fold it with an extra layer of paper in there to make it actually fit into these bags. And to connect to these sensors, I have here washers. Just standard washers, really. Oh, the video feed seems to have resynced. Maybe? No? Okay. It's being weird. Well, so, as I said before, I have here a piece of pre-folded and kind of pre-measured piece of aluminium, whatever you want to say. And I folded it 2 times, so we can make 2 sensors. If you only want to make 1 sensor, you fold it 1 time. So, oh yeah. So let's start building it. I also have some cable here. It's a standard DuPont cable. Handling aluminum foil is always tricky because it's so fragile. And things like here where it doesn't want to reopen properly. And it's gonna crease and kill itself. Oops, demonetized if I ever were. But I weren't, so yay. Also, I shouldn't have opened that all the way. Why did I do that? We're gonna open it once And we're gonna cut along this line that we have folded here. I mean, the way you make these strips is completely up to you. You could just freehand it. That's what I did with my first sensor, which is, it was a big sensor, about the size of this bag, I would say. A little bit smaller. But that's currently collecting data as we speak, and it has been doing so under at least statically 50 kilograms of pressure, up to 70 kilograms cyclically almost every day, or something like that. So, and it seems to be completely stable and accurate and repeatable. At least after you let it settle in. So I don't know how much of this is on camera, so we're just gonna do that. And oh Jesus, oh no. And we have our first fuck up, because I've changed direction. Oh well. Now, yeah, that was not the best. Yeah, we're gonna open this up, and we're gonna cut this again. Yoink. Ah. Why is it that when you start rolling the camera, everything just goes badly? Oh, come on, I'm not cutting there. Cut on the line, you freaking scissor. The scissor is like offset. Anger. Come on, cut on the... I'm freaking Tokyo drifting on this freaking foil. Come on, this is horrible. Okay, what if I just... Okay, that's the deal. Cut really, really small. Now when I've learned that, let's make this one proper. Or we can just realize that it's what's already cut. Yes. So, here's our 4 strips for our 2 sensors. I guess we'll pair this and this, given that I fucked it up a little bit. Oh well. So, now, to check, how big is this? It's big enough, good. So we're going to use the scissor again and get a wide enough so that it covers both strips completely and overlaps. So I'm going to choose yeah, there. We're going to fold on that line that I just cut there. I just nibbed it a little bit. Can you see? Yeah. And we're just going to align according to this edge. Wow, that actually worked for once. Strange. And now we will cut along this edge. Hopefully the scissor will not Tokyo drift on this paper. It's not, that's very nice. Thank you, scissor, for not doing that. There we go. That's for one sensor. I guess we'll start building one sensor. Or no. Let's be efficient. let's cut out for both of them. So that's I need to process this more, but let's. Oh god. Ah. Put that in there. Put that to the side for now. Whoops. Bring these in. And let's check overlap. I swear the breath changed the position. Something like that. And we are going to, again, nip the excess, or nip it so that it has excess, I should say. Is this even working? I don't know. Yes. It is. Interesting. I think. Not sure. But now that's been nipped in the side here. We will fold on that nip. Pulling it back. That's what I did before to make it line up. Let's see if it's true. Yeah. Interesting. That's supposedly how you're supposed to use a scissor. Long cuts instead of small cuts. It's what I've heard at least, or it's what I got taught in like first grade, I believe. I don't remember. Anyway, let's cut these in half now. Now these are going to be our insulators, and also our sensing elements, actually. These pieces of paper are what get compressed and change the capacitance of the capacitor that we're building, making it a pressure sensor. It changes under pressure. So the more you... Oh god. The more pressure you put on this paper, the more it compresses together, which makes these plates be closer to each other, which makes the capacitance go up. So yeah, works fairly reliably. Should I cut the other one? Nah. So let's actually build the sensor. And if you're doing a single layered sensor, we're going to be folding this. I don't know if I said that, to fit into these. If you're going to be folding it, you're going to need 2 pieces of paper. Otherwise, you just need 1. This extra piece basically makes an entirely extra capacitor in here, effectively, when it's all folded up. So not only are you multiplying by how many times you fold it, it's also implicitly multiplied by 2, because you have this extra piece of sensing element and capacitor in there. Or I I don't know. I haven't actually built one of these yet, but that's what I think is going to be happening. This foil is 5 times larger than this bag, and I expect to get about 10 times more efficiency because 5 times 2 is 10. But we'll see when I compare it to the reference sensor I have. Yeah. I'll update on that, I guess, in the description or something when I find that out, which may never happen. Who knows? So, maybe we should actually, what should we do first? Should we attach the wires, or should we actually build a capacitor? Something tells me it's going to be easier to build a capacitor on here and leave a corner like folded up, something like that, so that we can do the attachment here with the washers. I don't know. The first sensor I built the I put the wires on here first before I built the actual capacitors, and that was a little bit unwieldy. So I hope that can be prevented if I build a capacitor first. So how do we build this capacitor? Tape. This is a tape dispenser. And we're going to be using it to get this thing attached. I have tried using glue. It doesn't work because normal glue sticks is actually conductive, so you don't create a capacitor anymore, you create a resistor, effectively, which behaves very strangely when you try and measure it as a capacitor and like trying to force measurements with it. It's acting very weird. So tape it is, no glue. And what we're gonna start doing is just laying it so that it has ample clearance. I wonder how loud that is, but yeah, I'm just gonna do what I said earlier, which is just yeah, I think it's better to have the loose edge at where we have the excess. We'll see. I plan to roll it from this side, I guess. So we're just gonna put it down somewhere like so. Whoops. Nice, nice. Fold that over. So that's just going to be on there. I don't think we're going to have to put anything along here. Maybe you want to do that if you want extra repeatability in case the cell goes completely unloaded. Maybe? I don't know. I don't think I'm going to do that because there's always going to be load on these cells, and as long as there's some load on these cells, these things are basically not going to be moving. Especially not after you've been folding them. So that edge is on. I guess we put the other one on. Like, these are really simple to build. And when you place this one, the top one, you might want to maximize the area that they overlap, because we are building a capacitor after all. And this is not working. Okay, where about is it? There, which is... Oh, there, I can see it through if I just angle it at the light. Yeah, you can too. So we're just gonna quite literally line it up. And I think I fucked up because it might not be lined up with the actual paper here. So we're gonna be lifting the tape up and reposition it a bit. It is in the right anchor point. I just want it to be differently rotated. No, wrong. Yeah, I'm gonna have to lift even more of the tape. So, okay, lift that off entirely, redo it. I think I can see it through now anyway. So, there. Might have to replace that piece of tape since I lifted it a few times. There we go. Now we can fold that little piece over. And just to be secure with that, I'm going to pull out a little longer piece and just put it straight over the top, centrally. Something like so. And just walk it down either side. Not necessary. There we go. So we have some kind of construction here where there's foil, paper, foil. Now this is a regular single-sided sensor at this point. To make this double-sided, we're gonna have to put this on and tape this on as well, and then we're gonna have to fold it up. But before we do that, we're gonna have to attach some wires. So let's do that. And before we attach some wires as well, we're gonna have to kind of secure this down, at least somewhat, so that this lays somewhat in the same place when it's being used. So I guess the way to do this is to, since I want the other corner free, I'll put a piece of tape here. Oh geez. We're fine. We're fine. Which leaves me with this corner free. And maybe I can even put a piece of tape. Oh no. Oh no. The tape thing is jammed. This is not good. Not good opportunity for you to jam. Why did you put the thing there? Okay, it didn't jam, it just spat the tape out weirdly. Okay. Got tape from the anchor point. Pull some crap there. And wherever you overlay with air, basically, or where it sticks to the bench, I guess, you just fold over to the other side. So there we go. This side is basically attached. This edge here is free for us to attach a cable to. We're going to do the exact same here. So let's get a piece of tape. Let's pull this out. And yeah, I didn't really check what side I put against where, and to be frank, it doesn't actually matter with the attachment method we're going to be using, because the attachment method we're going to be using is friction. And we're going to be attaching to both sides anyway, so frankly it doesn't really matter. And this one is stubborn. Oh no, Jesus, it snapped. It snapped the paper. It's fine. We can fix it. First of all, fold over the tape like always. And now let's fix that little bit of damage that we did. Yeah, this is literally insignificant damage for the sensor. Only the active area is only between the plates. Any of this insulation here is not active sensor area, because that's not part of the capacitor. The capacitor exists between these two plates. Or foils, I guess. So let's put the other one here. See, that one pulled away easier. And again, just fold over. So here is a, I guess you could tape that down. I guess you could tape along this whole thing if you want. But if you're going to be putting them in the bag, like I am, I'm not sure you need to, so I'm not going to. And also because I'm going to be taping the rolled up thing. So I believe it's just not going to be needed, frankly. So there we have that. Now we're going to need to construct an attachment method. And here I just have some length of wire. Doesn't really matter how much. I'm going to be attaching both sensors to the same cable. So first of all, I'm going to do something like so. And then this is our two sensor cables for this sensor. I just said so because we're constructing the thing. We can do whatever we want. Whatever we want. Jesus, language. So what we're gonna do is separate these a bit. I said separate these a bit. Come on. There we go. Separated. Which means we can now expose the copper wire. Now this part doesn't require any soldering, because generally you can't solder, well, you can, but with regular techniques you cannot solder to aluminum. It just, like regular solder, doesn't work on that, on aluminum. So what we're gonna do is we're gonna trim out a fairly big piece of copper on both pieces here. Focus. Hey camera, focus. Hey camera. Oh well, that's about 12 millimeters, 1.2 centimeters. And these copper wires are going to be attached to this aluminum. Now, you can find solders to do that, but we're just not gonna deal with that because it costs a lot, and usually it's like silver solder and stuff like that. So what we're gonna use instead is a few washers. And a general what is this called? I don't know. Squeezer? Tong? It's a Knipex something. What does it say? I don't know. Knipex, whatever. But yes, we're gonna use this to bend these washers into a half moon kinda shape. Or, well, we're gonna basically take them, we're gonna take these rings and make them words. Whatever, I'll show you. So first, you take the washer, you put it half in, half outside, and you find a good thing to bend it against. So I'm gonna just rotate it against the table a little so that we get that. So it's kind of, see, it's kind of bent down the middle now. Now, once it's done that, you can again put it in here in a different way so that when you squeeze it together you can make that bend even more bendy, but you don't need to use like a table or something. So something like that, and we're just gonna be, and I lost it somewhere, and this is why I brought extras. Let's do all of that again. God damn it. Can't even pick this up. So, again, halfway in, halfway out, flat, roll it on a table edge. There I did it way too much to make it easy for myself. And also so that maybe the camera can see. Once I've put this in. I built one of these before. Why am I struggling? Oh, come on. Yeah, see how it's bent there? We're gonna... God damn it. The thing is, this is the end result we want. But we want it to be this way when there's foil and a cable in between the closing. So this is used up and fucked up, so we can't use that no more. So we're gonna make another one again. Third time's the charm, maybe. Okay. Maybe if I do it the other way. Oh yeah. Okay, there we go. So, what we have here is an almost closed washer. Hello, can you focus? Yeah, there you go. So that was a washer, and it's almost closed on itself. We're gonna use that as a friction fit. So what we're gonna do is when I get the cable, maybe we wanna spin the cable to make it more manageable. I don't know. Let's just spin it. Is this like copper-coated aluminium wire or something? This is not spinning well at all. How about this one? Yeah, this is not spinning well. This is probably copper-coated aluminium. Oh well, doesn't really matter. To me, where did I put that washer? Did I lose it? I lost it. Didn't I? Damn it. Oh yeah, there it is. Right in front of me. Yeah, here's the washer. Here's the cable. And we are going to rotate this around so that I can get access with this to clamp down on the washer whilst it's basically on here. So I'm gonna put that tool out of frame for now. But yeah, maybe I should do something like that. So, cable, aluminum foil, they're gonna be slightly overlapping. And then we're gonna use the washer to clamp them together. Now this might require a bit of finessing, and you might want to tape down the cable. In fact, it might be required. Also, building the capacitor before attaching the leads here might have been a mistake actually, because how am I going to be able to properly close it if there's paper in the way here? I'll worry about that later. For now, let's try and actually do this. Can't bring the camera any closer, but I'll try and make do. So, And we're going to be taping this down later. So the washer is there. It has one piece underneath the foil. The foil is on top. I might actually need to put... Actually, yeah, why? This is why I left it folded, or so I could fold it up to do this. Me unknowingly thinking ahead. So what we're gonna do is we're gonna put this almost closed thing back into here. There we go. And now we will attach it by aligning all the things up, putting the foil between. Actually, can I just rest this on here? I can. So we're gonna rest that on there, push it up into there, and close down on it, I guess. Oh, come on. Okay, let's try that again. Let's first check for damage. No damage to the foil, good. I think one edge of it snapped. It's on there. So there we go. One edge is on, and we're gonna tape that quite quickly, because aluminum foil is weak. Weak, I tell you. So we're gonna tape that down fast, so that it doesn't destroy it. Now, how this looks isn't really encouraging, but I assure you there is a connection there. If there isn't connection on top here, there's a connection on the underside. And yeah, we'll check it later anyway. And maybe we'll put one more piece of tape on there because tape. Wouldn't be a DIY build without tape. And there we go, one side done. Now for the other one. Lift up the edge. Make sure this is somewhat aligned. Oh, that's nice. That lines up very nicely. Oh, you can't really see because it's overexposed. Ah. Oh well. Wait, can I bring it? Can I bring the exposure down by putting this in the center of the frame? No? Maybe. But yeah. This aligns with this quite nicely. So let's prepare another squeezer connector friction thing from my washer. Let's move this out of the way. We want to give it moved. We want to give it move. We want to give it space to move, to bend over here when we start to roll it against the table, so that it's actually bent in the middle. That's good, I think. Let's try and make that close a bit more without actually closing it. Yeah, there you go. Oh, this is one of the better ones, I'd say. If the thing would focus. But yeah, you can definitely see what I'm going for there. So the foil just goes in the center there along with the wire, and then you just close it with the same tool. And that's what we're gonna do. So we're gonna put it back in the tool. This Knipex, tweezer, tong, plier, I don't know. Come on. Oh, this is embarrassing. Come on. Maybe I closed it too much. I can't actually properly get it in there in a good angle. Come on. Come on. Work, damn it. Okay, that's gonna have to do. Good enough. Hey, focus. Can you work? Focus? Camera? Hello, camera? Okay. Okay, yes. So let's do the other side of this thing. And might just do this one in the air. Yeah, this is definitely the most trickiest part. I mean, if you have silver solder and if you want to use it, go ahead, because this is painful. But yeah, there you go, it's on. And again, I kinda ripped the edge there a little bit, but it doesn't Again, doesn't really matter. And those are actually kind of aligned. Wow. Okay, that was not the best tape. Interesting. It just went, okay, I go by. Didn't want to be there. There we go, that's the sensor with wires connected, and at this point it's actually quite a robust sensor. It doesn't have a protective coating, still that's what this is for. So let's get it in there. And I'm not sure what to do with this extra piece of insulation here. It might be useful. So I mean, you could cut it out, but I'd rather just not. So what we're gonna do is that we're gonna define some folding lines. So that this can be, oh yeah, speaking of folding it, we need to have this there in between, or a bunch of tape if you want. It really is up to you what you want in between. But we need this to prevent shorting it, and since it's also the same material and it happens to be also making another capacitor, it just happens to amplify the effects even more. Sure, that works. Put this in the middle, I guess. There. Okay, so far so good. Come on. Why? Oh well. At least I have tape. Some don't have tape. Come on. Great. Now just basically the edge there left, which I'm just gonna be doing a simple fold over. So we have a sensor that's exposed on one side, and this side is actually going to be touching this. That's why we need the insulator there. So now let's start folding. Now when that is in place, the first fold is really ineffective, I guess, or you'll have double the insulation for one turn. That much, I guess. We shall see if that was the right choice. Let's get these tools out of here, they're in the way. But yeah, now we just fold and roll it over on itself. And this is what is the amplification part of the sensor. You're putting more sensing elements in the same area. And now, once we've folded it together, let's check that it fits its enclosure, which is going to be a plastic bag. It doesn't seem to be fitting. Bummer. Let's try and wind it tighter. Let's see if that works. Okay, it's actually like unfolding in its side there. Or it's not unfolding, but it's not taking well to maybe now. Huh. Well, look at that. It fits. So, that's a pressure sensor. A little bit thick, maybe. Yeah. This is the first time I craft these, so I guess I didn't foresee that. Yeah, I'm gonna tape mine together so that it holds the shape. on bottom and top, like so. And that's the sensor. Let's write some code to test this. I won't build the other one on stream because it's just a waste of time, frankly. But yeah, let's see. This is brown and red. Let's get those two. Brown and red. And we might not even need like to solder anything. Actually, I'll just solder a few. I'll just do this quickly. Luckily, I came prepared with a heated iron. Let's tin this. And let's tin the other one. I think it got tinned, I'm not sure. And let's put a little connector on there. On just those two for now. And oh, I thought I had a breadboard around to put this in. Maybe I do. Sure. That's just to put that there, so I can sink some heat away from it while I tin it and solder it. Yoink. Come on. Come on. Great. That's a weak connection, but that was a very weak connection indeed. It broke right away. So let's put on more tin. I said let's put on more tin. Come on. There you go. That's horrible, but it works. There we are. I have two connections there, so let's code. Let's bring some values from that thing, from this thing, and we might as well use one of these, I guess. Nice. I'm just gonna put that in there and put this so that one of these are on ground and the other one is somewhere else. Okay, I'm gonna put this actually over here so I can have some freedom. There we go. That does, however, mean I'm gonna need some male-to-male cables, which I have very little of. I say, as I have some right here. 2 is all I need. One, 2. One goes to the ground, the other one goes to your digital pin of choice. I'll show D5, sure. Reset. D0. D5. Okay, so we have it hooked up. We don't have code for it though. So let's whip some of that out real quick. First of all, let's see if this one is actually a working ESP. Okay, I still have this tape. Maybe something like that. There. Something like that. New Arduino, yes. Full screen. Here we are. Welcome to display capture. Okay, so here is our thing. First of all, make sure you can see. Let's define our pin to be, what was it, D5? I hate this. That little message, I hate that. But yeah, let's define that as D5. And that's going to be our sensor pin. So how do you interact with these very simple sensors? Well, you don't set them up really. You set them up during runtime. But we do want serial, so we can see serial.begin 115200. Sure, why not? Standard. And here in our loop is where we are actually gonna be measuring the sensor, and we're gonna print it out to the serial monitor. So first of all, let's create our thing that that keeps track of the sensor value. So value, set that to 0. And what we do then is set the pin mode of our pin, which is going to be D5, to be output. And what we then do is that we do digitalWrite pin low. Why low? Well, we want to get both plates of the capacitor close to the same to ground. So we're putting both of the plates to ground. One of the plates is always at ground, so we're pulling all the, we're pushing a bunch of electrons into these capacitors to make it to ground. Are we? Are we pulling them out? Whatever. Either way, we are pulling all the charge out of the capacitor. That's what we're doing. And we're gonna do that for some time. Let's do that for 10 microseconds, I guess. And then what we're gonna do is that we're gonna set pin mode of this pin to be input pull up. The pull up resistor inside most microprocessors is on the order of mega ohms, which means this capacitor that we have, which is fairly small when it comes to farads, like this is probably picofarads if anything. But since we have mega ohms of pull up, there's actually going to be a fairly amount of measurable time there that it's going to take that pull up resistor to actually get it up to a high state. And because it's an input, we can just read that state, and the time it takes to reach that basically says how much capacitance this thing has, given that the input or given that the pull-up resistor stays the same. So you're going to get different results from different pins because the pins are going to have all different pull-up resistors. They're really not that accurate, but they are going to be consistent within the pin you keep using. So we set it to pull up, which means the capacitor is now going to start charging, and we're going to measure the amount of time it takes. How do we do that? Well, we are just going to sit in a while loop and keep reading the pin, quite literally. So while it's 0, we're going to keep reading it. And we're also going to increase our value for each time we read it. It's basically how much time has passed in a way. And there you go. We're going to print line this so that we can plot it. But yeah, there it is. That's how you interact with these sensors. Yes, let's save that as that. This is all set up correctly. COM22, thank you. And I think we are good to go. Let's hope that this actually programs. It's a medium chance that it won't. I guess we could put the sensor in. Oh, it's programming. So compilation was successful. Let's put this sensor in the bag. Oh come on, this fit before. Okay, there we go. There we go. Serial monitor. Okay, here we go. We have values. It says 56. How much of that can you see? Not a lot. Yoink. Yes, yes, yes. Perfect. Here we go. So, the video is desynced. Clap, clap. Yeah, but as you see, we have a value of 56. Somewhat arbitrary. You can calibrate this later. But if I take my thumb and push down on it, you'll see that it's quite a robust, accurate, repeatable sensor. So let's switch over. Switch over to. Oh god, I really fricked this up, didn't I? Oh no. Yeah. So let's switch over to. Oh, come on. Switch over to the serial plotter instead, so we can see this a bit better. Yeah, that's fast. It's a fast readout. Really fast. Holy. Maybe I should do this thing a couple of times before I send it out. That's maybe a good thing. How much of this do you see? A bunch. Not everything. Yoink. So let's do this X amount of times, I guess. So already with just reading it once, we went from 56 to 90 something with just hand force. Quite good. But if you read it multiple times, say 10 times, and just don't reset the value in between, you're aggregating a measurement, basically. That should be there, I don't know. Yeah. So we're going to be measuring this 10 times, and if you want, I guess you could divide by 10 here, so we could get a normalized value to what the sensor would output on a single reading. Yeah, we could do that. So this is 10 readings averaged together, and it's not going to be quite as chaotic on here, I hope. Yeah, there we go. Still fast, really fast. You can't really even see because it's too fast with the graph. Maybe delay 5 milliseconds between each read, perhaps. Let's see if that helps to give the serial plotter a better idea of what's happening. Yeah, I guess. So what we have here is a really good sensor, in my opinion. Yeah. Oh yeah, maybe we want to actually see the values for that. Perhaps. So, yeah. This sensor is still new, so it began at 56-ish. It's gonna rise to probably around 65, maybe. before it's fully settled. But after that, it's settled and it's working fine. And yeah, there you go. Multiplied passive capacitive pressure sensor for sheep using aluminum foil and paper. And friction fit using, well, friction fit to cables using washers. Do I have any like standard units of weight here that we could calibrate against real quick? I don't think I do. Is there a standard weight for these SCART converters? Well, it changed. But yeah, it's... Ooh. Oh yeah, I forgot to speak about that. This pressure sensor, it doesn't really care about, well, it's not really a pressure sensor as it's a pressure over area sensor. Or I believe, I'm not sure, because if I compress here, it's only going to compress this part of the sensor and not everything else. So there's like levels to it. So if you want an actual force sensor, you maybe have to have a hard interface against this. But you're probably going to be putting this against a hard interface like a floor or between two hard interfaces anyway. So for all intents and purposes, it's a pressure sensor, really. Yeah, I should stop playing around and do something else, I guess. So yeah, that's all for today. Goodbye. I'll be putting the sample code this sample code. I mean, you could copy it off screen, but I'm going to put this in the description, so you can do this as well. I guess I'll quickly change this to be... nah. Or should I? Should I not? If I should, what should I name it? Read amount. Readings. Readings is 10. Readings or reading amount. This is the problem with programming. What do you name things? Let's just name it amount. Amount of readings. And this here, delay 10 microseconds, that's just an arbitrary time period to reset the capacitor here back to a grounded state. The shorter you can make this, the faster you can read the sensor. The bigger you have it, the more you can be ensured that the capacitor is actually emptied. It shouldn't take too long since you switch input mode to just basically force everything out of there as fast as possible instead of forcing it through the pull-up. But yeah, maybe that could change as well. Maybe this could change. But yeah, I'll leave the timings like this. And all of this is, yeah, I'll put this in the description. Have fun making passive sensors, passive capacitive sensors. That also happen to be, well, if you want to, you can fold them and multiply them like so. But probably not entirely needed. Like, it's a good sensor. There we go. Yeah, seems quite linear. It's all gonna depend on the paper, of course. But yeah, I'm out of things to say. I'm wasting time, so yeah. Goodbye. See you.